Guys, today we're going to do Unit 9, Lesson 1, the area of a triangle. So in the past you've learned about the area of the triangle, and the formula you are most comfortable with is area equals 1/2 base times height. But the problem with that formula is that only works if you have a right triangle, and we've learned that sometimes we don't always have a right triangle. So this lesson is going to introduce a new formula to you that you can use for a non-right triangle. The formula can be found on your reference sheet, so again, this is not a formula that you need to memorize. So let's just review some of the basics. Remember sine, cosine, and tangent, or we like to refer to them as SOHCAHTOA, right? So the sine is the two sides that the sine function deals with is opposite and hypotenuse. Cosine is adjacent and hypotenuse, and tangent is opposite and adjacent. So let's look at this first question. It says, in triangle ABC shown below, AC is 8, BC is 12, and the measurement of angle C is 56 degrees. Determine the height of the triangle in terms of the sine of 56. So we have the sine of 56, and we know that the sine function, so if I'm standing here, is the opposite side, which in this case is h, over the hypotenuse, which is 8. I'm going to go ahead and turn this into a proportion so I can cross multiply. So I have h equals 8 times the sine of 56. Determine the area of the triangle. Round your answer to the nearest square inch. Well, since this is a right triangle, we can use area equals 1/2 base times height. And in this case, the base value is 12, and the height is what we found in part A. So I'm going to say the area equals 1/2 the base, which is 12, times the height, which is 8 times the sine of 56. Now if you put all that in your calculator, let me see if mine's going to work. Okay, so we have, I'm going to use 0.5 times 12 times 8 sine of 56. And before I hit enter, I want to go ahead and make sure, see, I am in radian mode. I want to make sure I'm in degree mode. I hit enter. I had 39.79380,348. The directions said round your answer to the nearest square inch. So we're going to go ahead and round this 39.7 up to 40. So the area of this triangle is 40 inches squared. Now we're going to introduce the formula for the area of a triangle. The formula for the area of a non-right triangle is area equals 1/2 AB sine of C. So let's talk about that AB sine of C. So I have the measurement of the angle of C, and I'm going to use side A and side B. So in order to use this formula, you need the two sides and the included angle. So the angle in between those two side measurements. And if you look from the example before, that's exactly what we did. We did the side, right, times the side, times the sine of the included angle. So it's kind of neat how that works out. Which of the following represents the exact area in square inches of an equilateral triangle whose sides have lengths of 10 inches? So lots of vocabulary going on here. So let's draw a picture. Equilateral triangle means that all the side measurements are the same, and they're telling us each side has a length of 10. And since it's an equilateral triangle, we know that all the angles are the same. So in a triangle, there's 180 degrees. Divide that by 3 angles, and each angle has a measurement of 60 degrees. So in order to use the formula, area equals 1/2. I need a side value. Let's do this in red. A side, and the included angle. So it's going to be side, and then sine of 60. I also want to point out this part right here. It says the exact area. So let's see what happens there. So area equals, well, 1/2 times 10 times 10. Well, 10 times 10 is 100. Half of 100 is 50. And if you look, the sine of 60, you're going to have to remember, and these are not on your reference sheet. Remember when you had this 30, 60, 90 reference triangle? Across from the 30 is 1, radical 3, 2. So the sine of 60 degrees is going to be, if I'm standing here, opposite side measurement over the hypotenuse. So this would be 50 divided by 2 is 25, radical 3. Okay, so a lot of vocabulary in there. You had to remember your 30, 60, 90 reference triangle, and then you had to apply the area of a triangle formula. So that one, the answer was 4. Exercise 3, another vocabulary word. An isosceles triangle has legs of 12 inches and base angles that measure 32 degrees each. Find the area of this triangle to the nearest tenth of a square inch. Draw a picture to illustrate the triangle. I kind of just draw a standard looking triangle. Isosceles. So now we have to think, what does isosceles mean? Isosceles means that the two sides are congruent. So that means that this side is 12, this side is 12, and it says the base angles. Well, since these two sides are congruent, the base angles are also congruent. It says find the area of this triangle. So let's start with our formula. Area equals 1/2 AB sinus C. And if you remember, what do we need to use this formula? Well, we need a side, the included angle, and a side. Well, if I look at my picture, if I want to use this side, I could use this angle right here, but I don't have the value of this side. And since it's a right triangle, it's not a right triangle, I can't use Pythagorean theorem to try to figure out that missing side length. So let's see, let's go the other way. So I have this side, I don't have this angle, but I do have this side, so I'm more comfortable using that. So let's see. Well, I know that there's 180 degrees in a triangle. 32 plus 32 is 64 degrees, so 64 degrees are already accounted for. So I do 180 minus 64. I get a value of 116. So this angle right here has to be 116 degrees. I'm happy because I have the side, the included angle, and the side. I can go ahead and use my formula. So area equals 1/2 my side of 12, the other side of 12, the sine of 116. Area equals, and what did they want me to round it to? The nearest tenth. So again, I'm going to do and I'm sorry about that. For some reason, my calculators decided not to work and have a major attitude issue. So you'll just have to trust my judgment here. When I put all that in my calculator, again, make sure you're in degree mode. You get 64.7 inches squared. Exercise 4. In triangle ABC as shown below, AC is 24 centimeters, BC is 30 centimeters, and the measurement of angle C is 40. Determine the area of triangle ABC to the nearest square centimeter. Well, this is kind of nice. I have a side, I have the included angle, and I have the side, so I'm just going to directly substitute into that formula. And if you notice, I'm not getting all caught up on A, B, sine, C, all these things. I just remember I want the side, the included angle, and then the side. So, and it's multiplication, so we know that that commutative property says the order doesn't matter. We could multiply 1/2 30 times 24 or the other way. All right, so you're going to have to trust me again. When I type this into my calculator, I get 231.403, bunch of other numbers. It wanted it to the nearest square centimeter, so 233.4 is going to go ahead and stay at 231 centimeters squared. Using your answer from part A, determine the length of the altitude drawn from B to side C, to side AC. So let me just put that altitude in there. And if you remember, what does an altitude do? An altitude creates a 90-degree angle. So in this case, I'm going to go ahead and see what happens when I use area equals 1/2 base times height. So, do I have enough information here? Well, from the previous example, I know the area is 231, 1/2. I know that the base Well, let's see. You might want to use 30, but where is my altitude being drawn to? It's being drawn here, so that becomes my base. And the question asked me to solve for that, the height, so I'm going to put an H. So I have 231 equals, well, half of 24 is 12. Divide both sides by 12 to solve for H. 231 divided by 12 is 19.25. So that would be the height, or the length of the altitude. Exercise 5. A garden plot is being designed in the shape of a parallelogram whose sides have lengths of 40 feet and 30 feet. If the acute angles of the parallelogram measure 45 degrees, determine to the nearest square foot the area of the garden. So they said we had a parallelogram. The sides measure, well, I'm going to label this one 40 and 30. And we know this is 40 and this is 30. And it says the acute angle of the parallelogram measures 45. So let's see, what do we got going on here? Well, I know my parallelogram property says, well, parallelogram is just consisted of two triangles. So I know the formula for the area of a triangle. And in order to use that formula, I need a side, the included angle, and a side, which I have. So let's see if I can figure out the area of one of these triangles, and then I'll just take that value, multiply it by 2, and I will get the area of the parallelogram. Area equals 1/2 30, 40, sine of 45. And when you type that all in your calculator, you get 424.264, a bunch of other numbers. But remember, that is just the area for the triangle. In a parallelogram, I have two triangles. So I get 848.528 with a bunch of other numbers. So the area of this parallelogram to the nearest square foot would be 849 feet squared. All right, well, thanks for joining in today. And remember, we covered the area of a triangle today. The reason why we couldn't use area equals 1/2 base times height was because sometimes we're not given a 90-degree triangle or a right triangle. So we had to use this formula here. The formula is found on your reference sheet, so you do not have to memorize it. And it just requires the side, the included angle, and then the side. All right, have a good night.